Hello, this is VG Shanmugapriya. Today we will be seeing dynamic programming algorithm for n-free alignment. Dynamic programming is an optimal alignment algorithm for pairwise sequence alignment as it identifies alignment with highest score. Using this algorithm, we can do global alignment, we can do local sequence alignment and n-free alignment or semi-global alignment. Global sequence alignment is for comparing two related sequences which will be having similar length. They are aligned from end to end. Whereas in local alignment, we identify only the conserved regions when we are comparing the sequences which are distantly related. So here, only subsequences will be aligned and other regions including the ends are not included in the alignment. Whereas n-free alignment is done to identify overlapping regions between two sequences. Here the ends has to be included in the alignment. N-free alignment is mainly applied in genome sequencing to find the overlapping regions between the reads to build the contigs. So here these are the reads, that is a small stretch of sequences. Overlapping regions between these sequences are found out and then it is used to build the contig sequence. As we see, global alignment algorithm is done using Needleman-Wunsch algorithm and local alignment is done using Smith-Waterman algorithm. If you want to know about these two algorithms in detail, kindly watch my video on dynamic programming which will be displayed at the end. N-free alignment of sequences, it engages both the algorithms, of which global alignment is applied more. So let's see about this N-free alignment algorithm in detail with an example. Given two DNA sequence stretches and scores of match, mismatch and gap penalty, let's see how to do a N-free alignment. For this, first construct a matrix of Fij indexed with I and j, one index for each sequence on x and y axis. As shown here, include a gap position on each axis and then write the sequences. Later, mark the sequence positions. Begin the matrix by initializing F00 position as 0 and also fill the first row and first column positions with 0. This is to make sure that during sequence alignment, the end gaps have no penalty. Next, starting from this column, the other cells has to be filled using the global alignment formula as shown here. So to fill a box or cell which is indicated by Fij position, values from nearby three boxes are considered. I-1, j-1 indicates the box which is diagonal to it and j-1 indicates the box which is above it and I-1 indicates the box which is left side to it. So as per the formula, value from the diagonal box has to be added with the score of the residues being aligned. It might be a match score or a mismatch score. And for the other two boxes, the values in these boxes has to be added with the gap penalty score. So once this calculation is done, the maximum value obtained will be taken as the value of this box and a pointer will be placed from which box the value is derived. So this equation is repeatedly applied to fill all the cells in the matrix. While filling, a pointer is kept for each box back from which that Fij was derived. So this is the filled matrix with the pointers placed. Now next step in this N-free alignment is we need to choose the highest value either from this last column or from the last row. In this we can see that this box has the highest value. So next we need to do a trace back from this box. So here is how the trace back will be there. According to this trace back path, we know these residues will be aligned. Next thing is we need to extend the path in both the directions like shown here. So the path will be extended in both the directions like this. And based on the rule, we align the sequences. Here a diagonal arrow, if it is there, we know the residue in both the sequences has to be aligned. And if there is an horizontal arrow, a residue in sequence 1 will be aligned with gap in sequence 2. This one. Okay, so we align like this. And next thing is a vertical move. A residue in sequence 2 will be aligned with gap in sequence 1. So we have vertical arrow where we can align like this. So now to verify the alignment, we need to consider the given scores. So we have all matches over here. End-free alignment, as we have already seen, there is no gap penalty for the end gaps here. So we have a total score of 8. This is equal to the score which is found in this box from where we have begun our trace back. This proves that the alignment done is correct. Based on the alignment, we can now overlap the sequences and write a consensus sequences over here. So this is about n-free alignment. Hope you like this video. Kindly subscribe to my channel. Thank you. In this dynamic programming video for global and local alignment, you can have a detailed explanation of filling the matrix boxes using the formula and directly in the matrix box.